So in the last lesson, we talked about modular arrays, and we talked about how modular arrays are typically two controllers in an active passive configuration, and how modular arrays are really probably the most common storage array in the market today. And just about every major storage vendor has one, because for most environments and most organizations, it's a great entry-level storage system to get into that really has all the feature sets that most any enterprise or any organization needs. But sometimes those requirements go beyond what a modular storage array can do. And we talked about some of the limitations there about being a vertical scale-up type of architecture. And that's where we get into clustered arrays. So cluster arrays or grid arrays essentially take the concept of modular arrays and take it one step further in terms of the options and when it comes to scalability for both capacity and performance. So with cluster arrays, you can have two controllers, but very often you can go beyond two controllers. In fact, you can go to 3, 4, 5, 6, in some cases dozens of controllers in a very large grid type of array. And at that point, you can get past that two controller model. It gives you all sorts of options from a scalability perspective. We looked at how the two controller model had some limitations. You outgrow those two controllers, you'd have to typically swap out the hardware, or in some cases do a forklift upgrade of the entire modular array. With cluster arrays, every time I need to scale performance, let's say I need more cache or I need to have more performance from my storage controller, I just slap another node or controller on there and I'm able to increase my performance and meet those requirements without making any substantial upgrades or ripping and replacing hardware. Cluster arrays are what I define as true active-active because you move into this higher end enterprise array, you're dealing with an architecture that adds another layer of abstraction, and with all the multiple controllers you have, it pretty much allows any controller to take an incoming I/O and on the back end route it to where it needs to go with regards to the disk that data or disks that data resides on. So it's a true active-active solution, meaning you can load balance as you add controllers to the environment. You can effectively load balance your workloads in a clustered array. Clustered arrays, just like modular arrays, highly redundant, but I would say that they're even more redundant than the modular arrays because you're adding that many more controllers to the mix. You're not only scaling both performance from a caching CPU perspective, but also from a storage perspective, you're adding also that much more redundancy. So you start getting in the top tier, you start talking 4 or 5 nines of availability, and there's some vendors that actually guarantee on their higher end systems no downtime. So these are, again, very, very redundant architectures. Hot swappable, so same characteristics there as a modular array. But the big thing is with a cluster array is what we call a scale out or horizontal architecture. So the modular array was vertical or scale up. You had two controllers and you could scale up your disk storage, but you were limited to those two controllers. With scale out means I can scale out now my storage to multiple racks because I can add more than two controllers as well as the disk enclosures or disk shelves to my configuration. So it's almost like adding multiple modular arrays into a giant cluster and making it one giant storage array. Let's look at an animation. It'll probably be a little easier to see it visually. So let's look at a clustered array. So we have our LAN or SAN. Really, the network topology and protocols really don't matter. Most cluster arrays, like modular arrays, support the same protocols. In this example, we have basically 6 controllers in this setup. So think of it as if these were modular arrays, we had 3 modular arrays. Each one of them has its own set of CPU and cache and providing performance. On the back end, they had their own disk arrays with their own disks behind there. And as you can see, each one of these controllers is interconnected with its own clustering link or network that allows these different controllers or nodes to communicate with each other. So as you can see, with a traditional modular array, I'd have 3 modular arrays, each independent, but when a clustered array, you're essentially having one giant storage array, and I'm actually able to add these nodes or these storage controllers as I need performance. If I need more cache or CPU, I just add another storage controller. If I need more disk, I just add another shelf. So it gives you ultimate scale across across any requirement. So this is why these storage arrays are so very expensive and high end. And this is when you start talking about, the higher end EMC systems like the VMAX, Symmetrix, DMX. Hitachi had their VSP or USP product line. NetApp has their clustered on tap. So you start talking about these type of architectures, and they're highly redundant and can highly scale to meet the requirements of even the largest organization. So at a high level, this covers what a clustered array is. See you in the next lesson.